Okay, so what we're working on today is statistics, a little bit of statistics. This is the only chapter that we're not doing this year. So we're just doing a little bit. Okay, so given the following data, find the standard deviation. So what we're going to talk about today is standard deviation, which is something that I don't think that you guys have seen before in middle school. Standard deviation. That's going to be the new topic. And then we're going to also talk about the mean, because you're going to need the mean as well. So I'll put old was the mean. And the mean in statistics is the same as the average. Okay, so the average. And technically it's the arithmetic mean, and there's also something called the geometric mean. So to find the average, you add all the values. And then you divide by the number of data values. Okay, so for example, you have the numbers, and then let me show you I'll show you the standard deviation at the same time. So I'll start with example 1, and then I'll tell you how standard deviation works. Okay, so you have these numbers: 3 feet, 4 feet, 5 feet, 6 feet, 7 feet. Okay, and it asks you to find the mean and the standard deviation. And I haven't shown you how to find the standard deviation yet, but find the mean and the standard deviation. Okay, so the mean and the mean, there's some abbreviations for it. So I'll give you the abbreviation. The abbreviation is X with a bar over it. Sometimes people call it X bar. Okay. Okay, and X bar, which is the mean, means you add the numbers and then you divide by how many there are. So there's a notation. You guys don't know yet, so I won't use that notation. But we're going to add the numbers. And so we'll put add numbers, divide by, I'm going to call it N so that you're more familiar with the notation that we use in statistics as well. Okay, so in this case, you're going to add the numbers 3 plus 4 plus 5 plus 6 plus 7, and then divide by the number of numbers, which is 5. Okay, and let me expand this back out so I can see you commented. Okay, so usually when you're doing statistics, they let you use a calculator. But it's good to be able to do it with and without a calculator. So this is 7 plus 7 is 14, 20, 25. So 25 divided by 5 is 5. So the mean is 5. Okay, I'm going to show you another set of data. Okay, I want to show you another set of data. And I'm going to leave a space, so you don't have to write this one down yet, because we have quite a few steps. Okay, but I'm gonna make my other set of data here at the bottom. I just want you to be able to see both at the same time. Let's go back to this. Okay, but we need a lot of steps, so you don't have to write this one down yet. When we get to it, you'll see it. Okay, so look at this set of data instead. 1, 2, 5, 8, and 9. Now, if you look at the original set of data and the new set of data, it turns out that their average is 5 in each of them. But there's a difference between the data. Say this was, well, they're feet, so it's not a really good example to give you what it means. But if I kind of plotted these on a number line, 1, 2, and then 5's over here, and then 8 and 9. And then if I did the other ones on a number line, they're 3, 4, 5, 6, 7. Do you see how these are more spread out? And then these are more kind of packed in? Okay, so if you have more spread out numbers and then more packed in numbers, we want to have a representation of kind of spread outness. Okay, and that's what standard deviation does, is it figures out how spread out your data is. Okay, so let's, I'll write that over here on the side. So standard deviation is a measure of how spread out data is. I'm just going to type an answer to that question. Okay, standard deviation is a measure of how spread out the data is. So I would think that of these two data sets, the second one is more spread out than the first one. So the standard deviation will be larger in the second one compared to the first one. Okay, so let me show you the formula. There's a formula. Okay, I'm going to call it, what I call it is, so we'll call it SD for standard deviation. Okay, so SD, and let me give you the list. So what I write is A, D squared, A, and then square root. So I'm going to show you how to use those 4 steps. There's kind of 5 steps. D and squared are 2 different steps. I'm going to show you how to use these steps to get the standard deviation. So let me tell you what all the letters stand for. Okay, so A, the 2 A's actually stand for the same thing. So A stands for average. So you're going to find the average, which is the mean that we just found. So that's step 1. So step 1, you find the average. D stands for, you're going to find the differences between each and X bar, the average. And then I'm going to change colors for this one. You're going to square each one. Oops, let me move that. You're going to square each difference. And I'll show you how to do it. It's actually not very difficult. It's just that you have to do it in the order. A stands for average. And then square root stands for square root. Okay, so let me show you how it works. First, you find the average. So I'm going to circle the number 5 here, or box it so you could see it. So first thing is I find the average. And then what I do is I find out how far away is 5 away from each of these values. Okay, so for step 2, I'll do this one in another color. Well, maybe I shouldn't do that. Okay, so step 2 is, so this is the A, and right now I'm on the D. Okay, so what D is you find the difference between 5 and 3, the difference between 5 and 4, the difference between 5 and 5, the difference between 5 and 6, and the difference between 5 and 7. So the difference between 5 and 3 is 2. And you kind of just put commas. So what's the difference between 5 and 4? You can type your answer. What's the difference between 5 and 4? So 1. And then what's the difference between 5 and 5? Kind of you're asking yourself, how far is 5 away from the middle? Exactly, 0. How far is 6 away from 5? 1. And how far is 7 away from 5? 2, exactly. So in actual AP stats that I want you guys to take as a senior, the signs matter, negatives and positives. But in our class, it doesn't. And I only teach it with signs when I actually go to AP stats. Before that, I don't like to teach it with signs. Because the very next step, you're going to square them. So it's easier to square them when they're positive, and you get the same answer if they're positive or negative. Okay, so the little squares means you square each one. 4, 1, 0, 1, and 4. Okay, so this step here, step 2, has a D and then a squared. First, I find the differences, and then I square it. Now, I'm gonna move this example 2 down. Okay. So step 3 is A. So A stands for average. So I take the squareds that I just did, and I average them. So what should I divide by? How many numbers are there? Exactly. So you're going to divide by 5. So I get 5. So that's 10 divided by 5, which is 2. That's so funny because, oh, I didn't write all the numbers correctly. Oh, that's funny. I was using an example that I've used in the past, and I had this weird answer, like square root of 16 over 6. And I was thinking, how weird. I wonder why I made that up like that. But my 7 was an 8, not a 7, and that it kind of messed everything up. Okay, so anyway, so this is a problem. So that's 2. And then 2 actually has a name. So in the future, we'll put future. It's called the variance equals 2. Okay, but you don't have to know that in Algebra 1, and usually not even in Algebra 2. So it's called the variance. Okay, but step 4 is I have to get back to unsquare things. And the reason for that is when I found the differences, it was still feet. But when I squared it, it's feet squared. And so right now I'm in feet squared. And so I have to undo the squared. So what you do is you just square root the previous line. So square root of 2. And then you're back to regular feet. I'm not going to have you do it with the units, but it just kind of helps understand why they need to be that way. So the square root of 2 and square root of 2 on the calculator is about 1.4. But we're focusing on the numbers. So the kind of the average spread outness, it's not exactly that, but that's kind of what you want to think of standard deviation to be, is 1.4. So the middle is 5, and then I'm kind of spread out like 1.4, 1.4, maybe go out 1.4 or twice 1.4 on each side is kind of the standard deviation. But we show it to you in Algebra 1, and then we keep getting more advanced as you go through the different classes. Okay, but so I'm expecting that this one is more spread out. Let me read your message. For step 4, I usually like to leave it with the square root, but I kind of wanted, so this is the actual answer. I just like to, for this specific problem, I just wanted you to be able to tell like how spread out it is. And with square root of 2, you can't really tell what number that is unless we came out with it as a decimal. So I would say generally I would just leave it square root of 2 as the answer. That's a good question. Okay, so example 2, I feel like this one's more spread out. When I put it on the number line, it looks more spread out. And most of the things with standard deviation and mean and median and all those things are not really for just 10 pieces of data. It's for if you have 1,000 pieces of data, and I wanted to kind of see, what the middle was, and I want to know, is it spread out? Is it close together? And so that's why we develop these terms, is to understand them with small pieces of data, but then to expand on them into large pieces of data later on, which is what statistics is about. Not AP stats specifically, but statistics, the subject in college. Okay, so let's do the same thing for this one. So our formula is A, D squared, A, square root. This is how you find the standard deviation, which is basically a measure of, is it spread out? Is it not spread out? Okay, so the first step is you're going to find the mean. So the mean means you add up the numbers and divide by how many numbers there are, which is 5. And I made it so that our mean was the same thing. Okay, so I made an example where the answer was the same. And then step 2 is I'm doing the differences from the 5 to each of these numbers. Okay, so why don't you guys type the differences again like you guys did last time? So what's the difference between 5 and 1? So this step, let me write A, this is my D, this is my D squared. This is my step 3, which is A again, and then step 4 is square root. Okay. So what are my, tell me what my differences are. What's the first difference? How far is 5 from 1? 4, exactly. Now, if you were in college statistics or in AP statistics, they do data value minus mean. So technically it would be -4, but I want to do it with positives. Because really, it's just how far away you are. It's really not important if it's negative or positive. We're just trying to see how spread out is it. And that 4 looks farther, definitely farther spread out than the last one, right? The last one was only 2. Okay, and then how far is 5 from 2? That's 3, right? How far is 5 from 5? That's 0. How far is 5 from 8? That's 3. How far is 5 from 9? That's 4. And these don't have to match. We'll put here, it's a coincidence that it matches, like the 4 and the 4 and the 3 and the 3. That's just a coincidence. That's because I tried to make the problem so that we would have a pretty mean and not an ugly mean, because then when you're finding the differences, like what if the mean was 5 3/4, and then you have to find the difference between the numbers, and it's more complicated. Okay, so D squared means you take each of these numbers and you square them. Well, I guess I should put the squares up here. Let me put the squares up here. So you're going to square each one. Let me erase this row. And then you put what you get. So that's 16, 9, 0, 9, and 16. And squaring them actually exaggerates the ones that are farther away. So it ends up showing that it's more spread out because of that. A is what? We re-add them and divide by 5. So A doesn't stand for add. It stands for average. Okay, so it stands for average. So that would be 25, 25 is 50. 50 divided by 5 is 10. So that's called the variance. And again, that's a future term. So you don't have to know that term this year. And then square root of 10 is your standard deviation. So this is your answer. Let me box it. And then just so we can kind of see how does that compare with 1? I mean, we know compared to square root of 2, it's definitely bigger. But I'm going to type it into my calculator. So square root of 10, square root of 10 is 3.16. So you can see that the 3.16 is more spread out than the 1.4. So the number says that it's more spread out. Now, if I had 50 numbers, I can't really look at all 50 numbers or 1,000 numbers. So this spread outness and what's the middle, which is the mean, kind of the mean. There's 3 measures of middle, actually. We'll talk more about that on Tuesday. But these different items like this is what is how we can look at big sets of data differently. Okay. Now, I'm not always going to divide by 5, right? So you're going to divide, make sure you divide by how many numbers there are? Okay. So that's called n. Anyway, so that's it. That's our lesson. It's just that formula. That's all I wanted to do today is standard deviation. And then we'll talk about, and mean. Mean is the average. We'll talk about median and the quartiles next Tuesday. Okay, and there won't be too many questions about this. So catch up on old homeworks. I'll make sure I post the problems today. I just want to find my good problems that I had before. I had some nice examples. So I want to make sure that I have those examples so that you don't have stress over numbers that don't work out very well. Okay, so I'll post that in just a few minutes. Okay, I'm going to stop recording. Let's see where my stop recording is. Stop recording.